ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಕಳೆದ ವಿಡಿಯೋದಲ್ಲಿ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಅಂಡರ್ ಇಂಟೆಗ್ರಲ್ ಸೈನ್ ಕಾನ್ಸೆಪ್ಟ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ವಿ. ಅಲ್ಲಿ ಲೆಬ್ನಿಟ್ಜ್ ರೂಲ್ನ ಸ್ಟೇಟ್ ಮಾಡಿದ್ವಿ ಮತ್ತು ಕೆಲವು ಪ್ರಾಬ್ಲಮ್ಸ್ನ ಕೂಡ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಸೊ ಈ ವಿಡಿಯೋದಲ್ಲಿ ಇನ್ನೊಂದೆರಡು ಪ್ರಾಬ್ಲಮ್ಸನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊತಾ ಇದ್ದೀನಿ. ಸೊ ಲಾಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಲಾಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡುವಾಗ ಲಾಸ್ಟ್ ವಿಡಿಯೋದಲ್ಲಿ ನಾನು ಅಲ್ಲಿ ಹೇಳಿದ್ದೆ ಯಾವುದೇ ಪ್ರಾಬ್ಲಮ್ಸನ್ನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರು ಕೂಡ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಅಂಡರ್ ಇಂಟೆಗ್ರಲ್ ಸೈನ್ ಕಾನ್ಸೆಪ್ಟಲ್ಲಿ ಲೆಬ್ನಿಟ್ಜ್ ರೂಲನ್ನು ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಅದೇ ರೀತಿ ಯೂಶುವಲ್ ಇಂಟಿಗ್ರೇಷನ್ ಕೂಡ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಎರಡನ್ನೂ ಕೂಡ ಪ್ಯಾರಲಲ್ ಆಗಿ ಯೂಸ್ ಮಾಡ್ತಾ ಇರ್ತೀವಿ ಅಂತ. ಸೊ ರಿಕಾಲಿಂಗ್ ದ್ಯಾಟ್ ಆ್ಯಂಡ್ ದ ಲೆಬ್ನಿಟ್ಜ್ ರೂಲ್ that is stated here, we shall move forward to few more problems. So recalling the Leibniz rule statement, we have if phi of alpha equal to integral a to b f of x comma alpha dx, then phi dash of alpha equal to integral a to b partial derivative of f with respect to alpha dx. This is what Leibniz rule says. So using this concept we are going to solve problems. So first problem I am going to consider here is, by using the rule for differentiation under integral sign, evaluate by using the rule for differentiation under integral sign, evaluate integral 0 to infinity e power minus x sin alpha x divided by x dx. So this integral we need to evaluate. Okay, solution. So here the first step is identifying phi of alpha. We need to evaluate this integral, means obviously this stands as phi of alpha. Let phi of alpha equal to integral 0 to infinity e power minus x sin alpha x divided by x dx. Now applying differentiation rule for differentiation under integral sign ಅಥವಾ applying Leibniz rule, we have phi dash of alpha equal to integral 0 to infinity, see e power minus x by x, this is independent of alpha, that we'll write separately, sin alpha x, differentiating it we'll be getting, derivative of sin alpha x is cos alpha x into derivative of alpha x with respect to alpha we are differentiating, we get x into dx. So this x get cancelled with this and we will be getting integral 0 to infinity e power minus x cos alpha x dx. This is a standard integral. We have a formula for this integral e power ax cos bx dx equal to e power ax divided by a square plus b square times a cos bx plus b sin bx. So using this you can check that we will be getting 1 by alpha square plus 1. We will be getting phi dash of alpha to be 1 by alpha square plus 1. So this is phi dash of alpha. Now integrating, see actually I want the value of this integral. The value of this integral, which is nothing but phi of alpha. So from this phi dash of alpha I should get phi of alpha, so we need to integrate this. So integrating we get phi of alpha to be tan inverse of alpha plus c. This c is the constant of integration. Now we need to find the value of c. For that put c equal to 0. Putting c equal to 0, put alpha equal to 0, put alpha equal to 0, that gives you phi of 0 equal to tan inverse 0 plus c. That is nothing but phi of 0 is c. On the other hand, if you look into this, if you take alpha equal to 0 here, e power minus x into sin 0 by x dx. So all thing will be 0. So phi of 0 is 0 by the definition. Therefore, C equal to 0. Hence, phi of alpha is hence phi of alpha is tan inverse alpha. So I'll write here only. Therefore, integral 0 to infinity e power minus x sin alpha x by x dx is equal to tan inverse of alpha. This is what we need to prove. So this is the first problem. And the next problem I'm going to consider is this one. Problem number 2. By the rule of differentiation under integral sign, evaluate integral 0 to infinity e power minus x square cos alpha x dx. This is very tricky problem, so you should be very much careful to solve this one. So two important points you have to recall to solve this problem. So one is this one, the rule of integration by parts. This one is this you have to keep in your mind. Integral u v dash dx equal to u into integral v. First function is u, integral second function is v. So integral a to b u v equal to first function u into integral of second function. That product should be evaluated between the limits a and b minus under integral sign derivative of first function into integral of second function into dx. This is one thing you have to keep in mind. And second point you have to keep in mind is integral 0 to infinity e power minus x square dx is equal to root pi by 2. So these two things you need to keep in your mind. Okay, now solution. Let phi of alpha to be integral 0 to infinity e power minus x square cos alpha x dx. Call this as equation 1. Integral 0 to infinity e power minus x cos alpha x dx. Applying Leibniz rule, we get phi dash of alpha equal to integral 0 to infinity e power minus x square into, see, e power minus x square is independent of alpha, so we'll write it as it is. Cos alpha x, differentiating, you get minus sin alpha x into x dx. Now I'll rewrite this as minus, that can be written outside, integral 0 to infinity x e power minus x square into sin alpha x dx. Further, I will multiply and divide it by 2, and then it becomes phi dash of alpha equal to minus 1 by 2 into integral 0 to infinity 2x e power minus x square into sin alpha x dx. Now let us stop here only. Before proceeding, I will first consider this integral. Put I equal to integral 2x e power minus x square dx. So only this much I am considering right now. Integral of 2x e power minus x square. So this is actually, if you use substitution method, put t equal to x square, then dt will be 2x dx. So this becomes I equal to 2x dx will be dt. So integral e power minus t dt. Integrating, that is minus e power minus t. So I is minus e power minus x square, close the bracket. So that is the value of integral 2x e power minus x square dx is minus e power minus x square. The value of this integral is minus e power minus x square. So keeping that in mind, now we will apply integration by parts, taking sin alpha x as the first function and 2x e power minus x square as the second function. So applying integration by parts, applying integration by parts, we get phi dash of alpha equal to, so integrating this becomes phi. So phi of alpha equal to minus 1 by 2 times first function, that is sin alpha x, into integral of second function. Integral of second function is integral of 2x e power minus x square, but we have computed integral of 2x e power minus x square is minus e power minus x. So minus e power minus x square. This should be evaluated between the limits minus under integral sign derivative of first function. So derivative of sin alpha x with respect to x, that is alpha cos alpha x into integral of second function, that is minus e power minus x square into dx. So now phi of alpha equal to, here if you apply upper limit e power minus infinity into sin infinity, that is 0, minus applying lower limit e power 0 into sin 0, again 0, so that whole thing will be 0. Here minus into minus you get plus, alpha can be taken outside, integral 0 to infinity e power minus x square cos alpha x dx. See, integral 0 to infinity e power minus x square cos alpha x dx is nothing but phi of alpha. So okay, this should be phi dash of alpha, right? Sorry, this should be phi dash of alpha. So phi dash of alpha equal to minus alpha by 2 into phi of alpha. Now I can take this phi of alpha left hand side, phi dash of alpha divided by phi of alpha equal to minus alpha by 2, or else you can write this as minus 1 by 2 into alpha. We have this result, integral f dash of x divided by f of x dx equal to log f of x. So using that result and integrating both the sides, we'll be getting integrating will be getting log phi of alpha equal to minus 1 by 2 into integral of alpha with respect to alpha. See, there is only one variable alpha, so obviously we need to integrate with respect to alpha plus constant c. Whenever we get logarithm function in one side, usually we take that constant to be logarithmic. So we get log of phi of alpha minus log c equal to minus 1 by 2 into alpha, integrating it will be alpha square by 2. So that implies log of phi of alpha by c is equal to minus alpha square by 4. That implies phi of alpha will be c into e power minus alpha square by 4. But we need to find the value of this c. So for that, put alpha equal to c. Okay, put alpha equal to 0. Put alpha equal to 0, then we get phi of 0 equal to c into e power 0, that is 1. So phi of 0 is 0. By definition, we have phi of alpha equal to integral 0 to infinity e power minus x square cos alpha x dx. If you put alpha equal to 0 here, then you get phi of 0 phi of 0 equal to integral 0 to infinity e power minus x square dx, the value of which is root pi by 2. Therefore, c is root pi by 2, and hence phi of alpha, hence phi of alpha equal to root pi by 2 into e power minus alpha square by 4. That completes the solution. So with this, we have discussed two problems on differentiation under integration. Next video, let us consider a few more problems.